A02 is going to call for a little bit of design. There are different ways to go through this exercise. One obvious way is just to take the sorting function provided to you in your textbook and try to re-implement it by remembering it. So if this is what you did, I really encourage you to try again and try something different. Instead of re-implementing the bubble sort that is presented in the textbook, try to come up with the simplest algorithm that you can, simplest sorting algorithm that you can think about. Okay, this little exercise of course won't make you like produce a very efficient sorting algorithm, most likely, but it will encourage you to try to design from scratch a little bit less trivial solution to a problem. Okay, so this is what we're going to do. This first video is going to be about trying to design our own sorting algorithm from scratch. So before even to start the implementation, let's take a scrap piece of paper and work out how we are going to sort our arrays. Well, we need to start, well, people think different way, well, but let's start with something concrete. Okay, let's start with an array of 3 elements. Everybody can sort an array of 3 elements. Okay, if I write 3 elements on a whiteboard and ask somebody to erase and move the numbers in the position of the array so that the array is sorted, let's say, in ascending order, everybody can do that. What is interesting from the programmer perspective is to take a problem that everybody can solve and to enunciate the steps of the solving of that problem in a very generic manner and in a manner that is also acceptable by a computer programming language. So this is really what an algorithm is about. This is really what programming at its core is about, problem solving. So okay, we have this array of 3 integers. Let's take a concrete example. My integers are, let's say, 1, 2, 3. How would I go about sorting this array? Well, I would do nothing. But how do I come to the conclusion that I have to do nothing? Well, I would compare, let's say, 1 and 2. Okay, I want to sort in increasing order, ascending order. So 1 is smaller than 2. I don't have anything to do. Then I would compare 1 and 3. I still don't have anything to do. Okay, so that tells me what? That tells me that 1 is at its legitimate place. Then what about 2? Well, let me compare 2 and 3. 2 is at its legitimate place, so we're done, right? Okay, so here's the logic to get us started. Now, whether this is correct or not, we are going to get into that in a couple of minutes, okay? So this is how I'm trying to discern how anybody is sorting an array of 3 integers. The logic that is coming out of this first shot at trying to formalize the process is that it seems that the game is about checking that 1 is at its rightful position compared to the rest of the array. And then checking whether 2 is at its rightful position as well. So the smallest number is going to go on the first slot. So I take the current content of the first slot and compare it with the next number and with the next number about that. Okay. Once I'm done making those comparisons, I'm sure that the first value here is indeed smaller than the second and smaller than the third. Then once I have identified the smallest number and I actually stored it inside of the first element of the array, I can focus my attention on the rest of the array. And I can reiterate this process. I can ask myself, okay, is the first element of the sub-array here at the right place? So I compare item number 2 with item number 3. The smallest one gets swapped into the first position, and then I'm done. Because the last step would be to consider a sub-array which is made of only one element, the last element of the array. So I'm not going to do that. Okay? Alright, so this is really in a nutshell, in a simplified version of what our algorithm is going to look like. So this is the first step into thinking through an algorithm. Now, can I try to take at least, a note on what the structure of this algorithm would be? Well, let's try to go toward a programming language description. What did I do? I started checking that the first item was at its place. Then I considered my problem was doing the same job in a subarray made of the remaining cells of the array. Okay, so it seems that my logic will be for each location, let's call it I, in the array. For each location in the array, and I is going to be varying between, well, this is a little bit of an implementation detail, but we start at 0, okay, and we go up to the size of the array, -1. Okay, so this -1 start at 0. Okay, maybe I'm getting into too many detail here, but the important idea is for each location I in the array, I'm going to repeat a couple of steps. What do I have to do? Well, compare, and I need to name my array. Let's call it data. Compare data index I with what? Well, with each over location j in the array. Wait a minute, is it really each over? Well, let's have a look again. If I am here, okay, hold on a minute, let me resize this window. Something that will be like more easily done actually with the mouse. Okay, if I am right here, I indeed compare myself to the two remaining elements. When I am considering element index 2, I'm comparing myself to only what's left of the array. So this is not 100% accurate what I wrote down. So let me try to rephrase it. What am I trying to do? I'm trying to compare data index I, with the remaining location, let's call them index j in the array, with each of them. That sounds like a loop. So let me try to reformulate this in terms of a loop. I'm going to keep that tidbit here. I'm going to compare data index I with something, alright, but I'm not quite sure yet what. So let's work on that. For each, let's call them remaining location in the array, index j. And j will have a value which is what? I plus 1, which is my next location, given the fact that I'm looking at location I currently in the outer loop, 2 and -1. This index will have to be adjusted probably. I can feel already that we can be off by 1 very easily in this exercise, but for now, let's keep them at that. For each remaining location index j, compare data index I with data index j. What does that mean to compare them? That means trying to figure out if data index I is at its right position in the array. We try to sort ascending. So really what we are talking about here is trying to say that data index I should be lesser than or equal data index j. So that's what we mean by comparing. So comparing mean if statement, right? So if this condition here is true, then what do I do? Oops. Well, nothing. If it's true, they're already in order. So let me look at the case when this relation is false instead. So now that we're operating with the opposite condition, let's see what we do. We are going to swap those two numbers around. Okay, if the first one, data index I, is not at its correct location in the array, it should be after data index j, meaning that data index j is more likely to be the candidate for being the smallest value in the remaining array. we are going to simply say that TMP, we did that already a couple of times, this is a classic programming thing, TMP equal data I equal data j, data index j, and data index j. I'm just swapping the content of two variable, okay, equal TMP, and we're done. So we have a sketch here of a very simple sorting algorithm. It's not as efficient, of course, as more refined version of sorting algorithm, but the good thing is that we came up with it from the start, from scratch, all by ourselves. So now the next step will be taking this general ID, implementing it, and while we're at it, we are going to actually take a closer look at those index and make sure, of course, that we don't have off by one error, either here or here. Okay, well, let's move on to the implementation phase now.